Good evening. My name is Corporal, member of Group 1. We are working on a self-service acoustic representation learning for joint speech recognition and intent classification in low-resource African languages. I work with Bengana Jimmy Jr., that is my group mate, and that is the project we're working on, and we're members of Group 1. The contents that we shall be discussing in this video include introduction, related work of our project, problem statement, research questions and objectives, research contributions, methodology and system architecture and mathematical foundations of each of the created models, dataset description, results, limitations, conclusions, and future work. References, then we acknowledge the team members. So the background and introduction of the project include the project goal is multilingual AI-powered voice agent, enabling real-time spoken customer care service at Kosi, Makerere University in several Ugandan languages. So the languages include the actually English, Lugbar, Luganda, Runyankore, Swahili, and Ateso. So these are the languages that we shall be working with in this project because of the data set that we were able to get. So we were limited to those languages. Why are we coming up with this project? 90% of the assistants serve only in high resource languages, that is English, so French, Chinese, and other high resource languages. Then that leaves out the local languages that we speak in Africa, or we zero it down to Uganda. So there is a big challenge if any of the students, parents, or staff wants to access information about the college using the local language. So we use salt copper dataset. So it was able to enable the first Ugandan language AI system. That is why we came up with that. So the approach we shall use is we shall use a translation model to translate from local languages to English, store courses information in a vector database, then utilize retrieval augmented generation to prompt a fine-tuned LLM. The LLM will act as the knowledge base for general language understanding, and then we will translate the output to local language and serve it to the user. So that is the approach. So the related work of this project include the sunflower pepper. It is a new approach to expanding coverage of African languages in large language models. So the model approach was Queen. Then the main idea of contribution is training and fine-tuning pre-trained model to add support for Ugandan languages. Then the results was the high quality but very large in size. So that was the result and the limitation. Then the other one was the multilingual machine translation with open large language models at practical scale. The model was the GPT model. Then the idea was live language translation. The results and the limitations were huge compute savings dependent on pre-trained encode quality. Then the third one were the 200 languages within a single AI model, a breakthrough in high quality machine translation, that is NLLB 200. So the main idea was direct language to language translation. Then the result was wide language support and large model size. The problem statements are the domain application problem. Courses has no digital service in local languages, yet it serves a diverse range of people who might not be proficient with English. We are talking about uh, a college in a big university that is serving the whole of the world, I can say. So with the African languages that are not included in most of the digital systems, so we are left behind. That's why we came up with that. Then the goal and the success criteria are answers questions from users in local language. You just click your local language and you're able to get the answer in your local language. So it understands user questions and applies them to courses knowledge base. Then the computational problem is high GPU and compute runtime. Then also we have large model sizes. So those are the challenges. Then, the computational problem. Then the challenge is limited language data for various Uganda languages. Uganda has a lot of languages, but we're only working with 8, so there is quite a limit on that. Then our research questions and objectives. We go with the research objective to develop and evaluate the course's digital assistant, a multilingual real-time AI assistant integrating Web2Vec, that is 2.0, XLSR, that is filter 3 for language identification, and LLB for language translation, then 5 for Mini for intent classification. A structured knowledge base for answer, retrieval, and response across 7 Uganda languages at courses Makerere. So that is the objective. Then the research contributions and output. We develop and outsource that. We developed and outsourced. I can't see that, but let me go to the next. We build a novel end-to-end LLM architecture that integrates multiple pre-trained encoders. We also deployed our first full functional AI event management system, providing public access to our data, asset, and model via an interactive UI chatbot. And we engineered and published a comprehensive developer API. That is what we did. Okay, I think I will invite my colleague to take us through this slide. Then I know I'll come in from them. Jim Junior?
Yes, good evening. I'm Bengana Jim Jr. and I'm going to take us through the other parts of the presentation. So we look at the methodology and system architecture of what we managed to build. So this is a high-level overview of how the system works. We have a user, we have the web UI, the front end that they interact with, and we have the backend, which is a fast API application with the model pipe, with the models on it. So it begins with the user asking a question via the web UI. Then the web UI sends a request to the fast API application, so with the question that was provided. Then the fast API runs the model pipeline, which translates, answers the question and generates out in the user's language, sends it back to UI, and then the web UI displays the response to the user. We can move on. Next slide. Then if you look at the internal model architecture and pipeline, how it's working. So we have the NLL B200 mini model that is in charge of translating the text from the local language to English. So what happens is, initially when the user provides their prompt in, like their question, asks a question in their local language, our model first translates it to English. Since our knowledge base is in English, like the courses data is available in English, so we have to first translate it to English. Then it sends it to a RAG prompt builder, and this RAG prompt builder is basically in charge of generating, querying the vector database that stores our information about courses. Then it generates a prompt, and then this prompt is passed to LLM. The LLM, in this case, we're using a Phi Mini 4 model, which is a large language model that understands general language, so it can easily structure the response into a reasonable output. Then this response is then sent back to the NLLB 200 mini model that is in charge of translate. So in this time, it's now translating from English back to the local language. And that final translation is what is given to the user. So that's how it works internally. So we can move on. So if we are to go to the model deployment, selection and deployment, we are to look at the models that we used in our system and how we deployed them. We used the Facebook NLLB 200 distilled model with 600 parameters. This one was in charge of language translation, from translating from English to local language, or from the local languages back to English. Then we also used the Microsoft's Phi Mini for instruct model, and this one was in charge of general language understanding, which it was generally the language model that we're using underneath our system. It's in charge of understanding, because it's a large language model. It can understand the user prompt and generate a reasonable output. Then we come to coding the courses data, the data about courses. We used the sentence transformers, all mini LM -L6 V2 model. This one was for encoding our courses information into vectors that were stored into the vector database. Then for deploying, we used the Google Colab for training and fine-tuning and EDA. Then we published our models and our datasets to Hugging Face. Then for hosting our system, it's hosted on Google Cloud Run. We are utilizing some GPUs, and we are deploying the REST API on Google Cloud Run. Then the web UI, the one that the user interacts with, is deployed on Verso on the link below, cmva.open.ug. And on the side, we have here a small illustration. So we can then move on to the dataset, a small illustration of how the system looks like. So we can move on. So the dataset description and exploratory data analysis. So we have two datasets that we used for this system. One was for language translation. Translations here we used the Sunbird AI, which it was used. This dataset was used on the Facebook NLLB, so that you can add in support for different languages for the local languages of Uganda, since Facebook's NLLB didn't provide them. And then we also have our own dataset for knowledge about courses, basically data we collected from the courses website. We generated our own dataset and published it. And then on the side, we are having a simple bar graph showing, let's say, the samples of different languages within the Sunbird AI, like Lugbar, Acholi, Ateso, yeah, and the rest. And so the limitations we faced, mainly the courses, the data about courses is limited and copyright, because majority of it is copyrighted. So you can't just use it into your dataset. There comes in some copyright issues. The translation data, some languages lack enough translations in the sole dataset. For example, but has little little samples compared to Ateso or Acholi. And also there are also very many other languages that are not within the sole dataset. Then when when it came to training, to the compute problems, training on Google Colab and Kaggle was kind of limited since we're using free versions that provide us with a few GPU resources, and since we're training LLMs, it requires enough resources. And lastly, the ethical, considering courses data is copyrighted, using it within your dataset raises some ethical concerns and legal concerns, since you might be infringing copyrights. Yeah. So, in conclusion, the courses assistant is a much needed tool by the College of Computing, since it promotes inclusion of the diverse populations of Uganda that may be involved within or interact with courses and want to know more information about courses. So providing different languages can be beneficial. And when it comes to future works, um, we aim to support more languages as we manage to collect more data, and maybe also support voice prompts for those users who cannot, let's say, read or write. And last slide, next slide. When it comes to references, we looked at different references, like the one of her, a one titled Language Translation Using Efficient Pre-trained Models, NLP Models. We looked at multilingual machine translations with large language models at practical scale. And also we looked at the Sunflower model by Sunbird AI in the paper, a new approach to expanding coverage of African languages. Next slide. And yeah, lastly, this was like acknowledgement to our team. It's me, Bengana Jim Jr., and my group mate, Akol Paul. And also we give thanks to our supervisor, Dr. Marvin Kaliwango. Thank you.
Thank you so much.